So hello, in this video, I'm going to discuss slope and y-intercept of the regression line. By the way, this will be the part 2 of our discussion on simple linear regression. So whenever there are more than 2 points of data, it is usually impossible to find one line that passes through all points. However, a best fit line that is a good approximation of the data can usually be found. These best fit straight line used to predict the value of y for a given value of x, and that is called the regression line. In statistics, there is a simpler way to find the equation of the best fit line. The equation of the best fit line is also called equation of the regression line, or simply regression equation. So the equation of the regression line is given by y hat equals bx plus a, where b stands for the slope of the regression line, while a is the y-intercept of the regression line. Just to give you some examples, we have here the regression line y hat equals 2x plus 3. As we can see, the value of b is 2, which is the slope, while a is 3. And y-intercept, that means the y-intercept is 3. We can locate here 2 and we can locate here 3. In this case, in the second example, we have your y hat equals x over 2 minus 1. As you can see, the value of b, or the slope, is 1/2, the coefficient of x, while a is -1. Since we have here minus 1, the value of a will be -1. So it means the slope is 1/2 and the y-intercept is -1. Whenever we are given a bivariate data and we do not know yet the regression line or the equation of the regression line, these are some helpful formula for calculating the slope and y-intercept of the regression line. So b equals the sample size multiplied by the summation of x and y minus the the product of the summation of x and the summation of y, and that will be divided by and multiplied, or the sample size multiplied by the summation of x squared minus the square of the summation of x. And that is for b. For a, we have the summation of y minus b summation of x all over n. So for us to obtain a, we must first find the value of b, because as we have seen here, we need the value of b for us to obtain the value of a. So in this slide, it will tell us how to determine or how to calculate the slope and y-intercept from a given set of data. And we are going to do this, or I will going to tell step by step. The first step is to make a data table with 4 columns. What are these 4 columns? We have here x, the independent variable, y, the dependent variable, so the summation of xy, and the square of x. So we also have to note the sample size, which is n. And we must know what is the value of n, or what is the sample size. That is the first step. The second step is to list the data for x and y. Okay, and then multiply x and y to get xy, square x to get x squared, and then we have to complete the table. So a third step will be find the sum of x, y, xy, and x squared by adding the values in each column. then substitute the solved values into the corresponding formula. So to give you an example, we have here a teacher believes that excellence is a fruit of hard work and persistence. That is why she wants to prove if the number of students' absences is related to their general average. On her gathered data, the recorded numbers of absences and general average in the recent semester are shown on the table. So what we need to find here is the equation of the regression line. So how are we going to do that? So doing the first three steps, we have here the first or the four columns x, y, xy, and x squared. So these are the given. Number of absences, 1, 2, 3, 5, 7, 9, and 10, and their corresponding average, 98, 90, 86, 87, 85, 85, 78. And then for this xy, we have to multiply 1 and 98, 2 and 90, and so on up to 10 and 78. And for x squared, we have to obtain the square of x. 1, 4, 9, 25, 49, 81, and 100. So after doing that, we have to compute for the summation of x, summation of y, summation of xy, and summation of x squared by adding all entries on this column. And for this, and for this. After doing so, we have here in a 7, summation of x as 37, summation of y 609, summation of xy 3111, and summation of x squared is 269. From that, we can calculate or we can use the formula to obtain the value of b. So let us compute. So we all know that n is 7. Summation of xy is 3111 minus summation of x, which is 37, summation of y, which is 609. N is 7, summation of x squared is 269. The square of summation of x is 37, hence we have here square of 37. So if we're going to plug this on your calculator without having this, you can obtain negative 1.47, and that will be the slope. So since we already have the value for negative, or we already have the value for the slope, which is negative 1.47, we're just going to plug it in our equation here. So b is negative 1.47 multiplied by summation of x, and the product will be subtracted from 609, which is summation of y all over n. And computing for this, we have 94.77, and that will be the y-intercept. And combining these two, we have the equation of the regression line as y hat equals negative 1.47x plus 94.77. And that is all for the second part of our video.